Today's learning target is I can estimate sums, differences, products, and quotients of fractions and mixed numbers. In today's lesson, we're going to be estimating. And if you remember, the whole point of estimating is to quickly get to an answer that's going to be fairly close. And you want to be able to do that easily. So the whole key to estimating is working with numbers that are easy to work with. So right now it's asking us to estimate what this answer would be, 3 2/3 plus 5 1/6. When I'm estimating, I want to be sure to change my numbers to numbers that are easy to work with. So in 3 2/3, now I know with 2/3, 2/3 is more than 1/2. And I know when my numerator is close to my denominator, like it is in this one, it's only one away, and it's more than 1/2, this is going to be close to a whole. So if I were going to round this, I would say, let's change this 3 2/3 to 4, because 4 is easier to work with. And now I have 5 1/6. Now I know that 1/6 is less than 1/2. And in fact, if I were to have 0.6, this would be worth 0. So it's fairly close to 0.6. So when I round this one to a number that's going to be nice and easy to work with, I'm just going to say this 1/6 is actually really close to 0. So let's just take 5. So if I'm going to estimate, now I use the numbers 4 plus 5, I can do that in my head, that's 9. So a good estimate for this answer would be 9. It's not going to be the exact answer, but it's going to be close. And the reason estimating can help me is now when I actually do solve it, I can see, is my answer close to 9? If it is, then I can be pretty confident that I'm right. There may be other times where you don't need an exact answer, and so it's just going to be faster to estimate. And a lot of times when you estimate, you can do it in your head, which is really nice as well. In this problem, I'm going to estimate a multiplication problem. So I have 6 2/5 times 1 7/8. So the first thing I want to do is get my numbers nice and easy to work with. So I'm going to take a look at this 6 2/5. Now, here's what I do with this 2/5. If you look right down here, this purple writing. So I'm always thinking to myself, any fraction, is it closer to 0 or is it closer to 1? And I use 1/2 as my kind of measuring point. So anything that's 1/2 or larger, I'm going to round to 1 because it's closer to 1. Anything that's less than 1/2, I round to 0. Okay, or I bring back to 0. So in this one, I have 2/5. So when I'm working with fractions, to find a half, my numerator up here would have to be half of my denominator. So in this case, I have 5. So I have to think to myself, what is half of 5? Well, let's see, if I split 5 in 2 equal groups, I would have 2.5, or 2.5 in each half. So I'd have 2.5. So my numerator would need to be 2.5 over 5 in order to be a half. Well, my numerator is 2, so I know this is less than 1/2. So I'm going to say this is closer to 0. And here's how that helps me. So I say this is 6, and then this fraction is just nothing, so I have 6 wholes. Now remember, I do this in my head, so it doesn't take that long. And now 6 7/8, or excuse me, 1 7/8. So I'm going to look at my fraction, and eighths is my denominator. So in my head, I'm thinking it would have to be 4/8 to be 1/2, and it's 7/8. So it's closer to 1. So I have 1 and another 1, so I have 2. So I'm going to round that one to 2. And now that's easy. 6 times 2 is easy to do in my head. I get 12. So my estimated answer for this one would be 12. So you probably noticed that the last few problems that we solved were mixed numbers. So we had a whole number, like 4, but we also had a fraction with it, like 2/3. Okay, so that's called a mixed number. And when we round these mixed numbers, with our fractions, we can figure out whether that fraction is closer to 0 or closer to 1 whole, because they're bigger numbers. And so You know, 2/3, I would think of this as closer to 1, so I'd say 4 and 1, that rounds to 5. However, if we're going to estimate fractions like we have here, okay, now I have to be a little more careful on what I round my fractions to, because if I just round everything to 0 or 1, I'm not going to have an estimate that's close enough to my real answer to help me. So for my fractions, I'm going to need to be a little more precise. I'm not just going to be able to say this is closer to 0 and this is closer to 1. Now sometimes it might be closer to 0 or closer to 1, but sometimes it might be closer to a half. Okay? For example, let's take this one right here, 3/7. Now, I look at my denominator and it's 7. Half of 7 I know is 3.5. Well, my numerator is 3. So I look at this and I say this is pretty close to 1/2. I know 3/6 is 1/2. So 3/7 is going to be close to 1/2. And 1/2 is fairly easy to work with. Now I'm going to add that to 3/4. Now when I look at 3/4, I do know that 3/4 is close to 1. So I might round this one to 1 because it is very close to 1. My numerator is only one number away from my denominator. I know that's close to 1 whole. So I'm going to change that to 1 whole. So now I have 1/2 plus 1 whole would be 1 and 1/2. Here I'm going to be estimating a subtraction problem. So here I'm looking at this first fraction, and 7/8. Now I know 8/8 would be 1 whole, so 7/8 is very close to that. 1's nice and easy to work with. Okay, now I look at my second fraction here, and it's 5/9. Now, ninths, let's see, half of 9 would be 4.5. So 4.5 over 9 would be 1/2, or 5/10 would be 1/2. That's very close to that. So I'm going to put 1/2 here. Now if I have a whole and I take away 1/2, I'm left with 1/2. In this division problem here, I'm asked to estimate 8/9 and divided by 5/6. So in this case, 8/9, in my head I'm thinking 9/9 is 1 whole. That's very close to 1 whole. So I'm going to go 1 whole divided by, and here I have 5/6. 6/6 would be 1 whole. So that's also close to 1 whole. So it's 1 divided by 1, which is going to be 1. So my estimated answer for this would be 1. I can also use compatible numbers to estimate. So when I do that, let's take a look at this problem here. So I have 1/3 times 14, or another way to say that is 1/3 of 14. Okay, so what this tells me, this fraction here, is I'm going to split this number into 3 equal groups. So if I split this number into 3 equal groups, so I'm going to put group 1, group 2, group 3. So I split that 14 into 3 equal groups. How much will be in there? Now, 14, it doesn't work to split equally here, but I do know in my head that if I were to do 15, I could put 5 in each one of these groups, and I would get 15. So I know that 1/3 of 15 would equal 5. So a good estimated answer for this would be 5. Now I want to point out a mistake I just made. Right here, this is not true because I've said 1/3 of 14 equals 5. That's not true. I've estimated. So instead of doing the equal sign, because they're not equal, I want to use what I show as my about sign, which is kind of like a wavy equal sign. So really what I should have written is 1/3 of 14, and this means is almost equal to, or is about equal to, or is close to 5. So that's how I should have written it with the estimate. So if you see an answer with kind of a wavy equal sign, that means it's estimated. Let's take a look at this one here, 9 7/8 divided by 4 1/5. Now, here again, I'm going to look at this, and as soon as I see this problem, I'm seeing that I could use some compatible numbers, because I see 9 7/8. Well, I know that's fairly close to 10. And now I look at 4 1/5. Now, if I were to to round this, it would round to 4. It's close to 4. But if I do 10 divided by 4, that's not a real easy problem to do in my head. But I could do 10 divided by 5. That's a problem I know. So 10 divided by 5 equals 2. So 9 7/8 divided by 4 1/5 is equal to about, and there's my wavy line, I won't make that mistake again, is equal to about 2. Alright, here's the last problem. Let's take a look at 1/6 times 20, or 1/6 of 20. Now I know that if I have 1/6 of a number, that's the same as dividing it by 6. Okay? So in my head, I'm thinking to myself, what number, 20 I can't divide by 6 easily, but what number is 20 close to that I could divide by 6? And when I do my counting, I think 6, 12, 18. Aha, 18. So 18 is close to 20. So I could look at this as 1/6 of 18. So if I broke this 18 into 6 equal parts, what number or how many would be in each equal part? Okay, it's another way of saying 6 times, or 6 groups of how many would give me 18? And my answer would be 3. I'd put 3 in each group. So 1/6 of 18 would equal 3, which means that 1/6 of 20 would be almost 3, or about 3.